Hello. In this lesson, I'm going to talk about quadratic equation, basic things about quadratic equation we should know. So let's begin with. So here this is the general form of quadratic equation. This ax square plus bx plus c is equal to 0. This is the general form of quadratic equation. We represent quadratic equation like this, and there are some conditions. There is a condition where a should not be equal to 0. If I put a is equal to 0, then this equation becomes bx plus c, bx plus c is equal to 0, which is a linear equation and it represents a straight line like this in the coordinate system if we talk about graphically. And generally, quadratic equations are parabolas. Uh, if we represent in the xy plane like this, it is a parabola represented graphically. It can be like this, it can be like this, and like this. We can alternate the values of ABC to get any kind of parabola we want to, if we want to. So this is a condition where a should not be equal to 0. So it can be quadratic equation. So basically, the word quadratic is the degree 2 in this variable. This is a variable x. So if the equation variable is 2, degree 2, it is a quadratic equation. If its variable degree is 1, so here x is 1, it is known as linear equation, or we can say it is a monomial. And if the degree is greater than or equal to 2, then it is known as polynomial. uh, and to find the solution for this equation, so basically solutions means the values of x satisfying this equation. So if we put x in here, it can it becomes 0. If we put x here, it becomes 0, so this equation becomes true. To to make this equation true, we have to put anything value x here. So this is a general formula for finding the roots or finding the solution for this equation, for this quadratic equation. So we can directly use this formula, or there are some methods. There are 2 or 3 methods I know, in which we can solve this manually, not remembering this. So if you remember this, it will be easier for you or not. There are several methods we can use. So let's say I take x square minus 1 is equal to 0. This is a quadratic equation. We can see that. Uh, so a is not equal to 0 in this case, and here b is 0. So it doesn't matter that b is 0 or c is not 0. A should be not 0. It is a must condition that a should be not equal to 0. Anything can be 0. X square is equal to 0 is also a quadratic equation. In this case, x is equal to 0 satisfy this equation. So x is equal to 0 is the root of this equation. And to represent this curve on the graph, so I'm drawing the xy plane. This is horizontal axis is x-axis, and vertical axis is y-axis. So if I take y is equal to x square curve, so we can draw manually without anything. So this becomes to be like this curve. This curve is like this. If we plot manually by using values, so let's plot by using values. Okay, right. But okay, here are x values, here are y values. So y is equal to x square. If I take x0, x1, x2, and -1, -2. Okay. So if I plug in x is equal to 0, then 0 squared is 0. So y also becomes 0. If I put uh, x is equal to 1, then y will be 1. So y will be 1. And if I put x is equal to 2, uh, 2, then y will be 4. And if I put x is equal to minus 1, it is plus 1, and minus 2, it is plus 4, because it is squared, x squared. We're dealing with x squared. So let's plot this right there. Mm, At x is equal to 0, I'm using another one. Okay. At x is equal to 0, x coordinate is 0, and y coordinate is also 0. And at x is equal to 1, let's say here is x is equal to 1, y is equal to 1. Okay. And this is x equal to 2, but this is y is equal to 4. So if this is x is equal to 2, this is y is equal to 4. And if this is negative 1, so y is positive 1, it coincides here. And if it is negative 2, and y is, so y is positive 4. And if we join these points, it forms a curve like this. I'm taking integers only. It also works with decimal numbers, decimal points. If I put point 1, then this also represent, in this case, we can see that there are decimal numbers between them. They are also included. Uh, for the sake of, to make this easy, I am using only integers. So we can see that this is forming a curve like this. So we can do manually. Okay. So this is y is equal to x square curve like this. We have plotted this manually. Okay. Let's solve another equation. This equation, x square minus 1 is equal to 0. So to solve this equation, I'm using a method. So x square minus 1. This is a formula, or you can say identity, a square minus b square identity, which is a plus b into a minus b. Yeah. This can be written as x square minus 1 square. 1 square is 1. So I can write this thing as x minus 1 into x plus 1. I can simplify this with this, and we are we have this thing right here. X minus 1 into x plus 1 is equal to 0. So uh, when do two numbers multiply and become 0? Either this will have to become 0 and this will have to become 0. Let me take an example. Okay. So if I take 0 into 2, it becomes 0. If I take x into 2 is equal to 0, then x should have to be 0 to become to do this thing true, to make this equation true. So either x minus 1 should be 0, or x plus 1 should be 0. So let's solve these two equations. If I add both plus 1 on both sides in this equation, then this 2 becomes cancelled, and we are left with x is equal to 1. This is a solution, and if I subtract both sides by negative 1, here we are left with x is equal to negative 1. So for this equation, x square minus 1 is equal to 0. These are the two solutions. That means if I plot graph, let's plot graph. The solutions are basically where it coincides with x-axis, where this curve coincides with x-axis. In this case, in the y is equal to x square equation, it is coinciding on 0 comma 0. We can see that x square is equal to 0 is becomes true when x is 0, and this becomes true. uh, X square minus 1 is equal to 0 becomes true when x is plus 1 or minus 1. Plus 1 or minus 1 means a curve like this here. This is x equal to plus 1, and this is x equal to minus 1. You can see that. So x square minus 1, y is equal to x square minus 1, y is equal to x square, x squared minus 1. Y is equal to x squared minus 1 curve looks like this. And let me talk about another thing. For this equation, uh, yeah, let me write f of x is equal to. So it is a function of x. Basically, it is a function ax square plus bx plus c. Mm, there is a thing with this value of a means if a is positive or negative, the curve alters with that thing also. We can predict the concavity of this curve. Concavity, concavity, not whether it goes upward or downwards. If a is positive, the curve goes like this. If a is negative, then the curve goes like this. So that means if a is negative, then this point is the maximum point for this curve, for this equation. The vertex, this is known as this is the lowest point for this curve is known as vertex. So this vertex right here, if the value of a is positive, if the sign of a is positive, then the vertex is the minimum for this curve, and the if a value is negative, then the vertex is maximum for this curve. So it is a point to be noticed, and this is the good point to be noted down. Okay. And one more thing. Okay, let me talk about one more thing. So there is a thing known as discriminant of quadratic equation, which decides the nature of the roots of this quadratic equation. So x values are the root of the quadratic equations, and to find the nature whether they are real or not, we use discriminant. So discriminant is denoted by delta or d. It is b squared minus 4ac. So if you have seen in this formula, minus b plus or minus b square minus 4ac by 2a. This is the solution for the quadratic equation. Okay, this is the solution of the quadratic equation. X value for the quadratic equation, and here we can see this term here. This is known as discriminant of the quadratic equation. So as we can see that this is under the root, and if there is anything value under the root is positive, then it is real. If anything under the root is negative, then it is imaginary, or imaginary, or we can say complex. So this thing will come in complex numbers. We do not need to worry about that. We are only dealing with now the nature of the roots, whether it is real or imaginary. So we can see that if this thing is positive, so if delta is positive, the roots of the equation is are real, are real. The roots of the equation are real. If this delta is negative, if this delta is less than 0, then the roots of the equation are imaginary. And if we put delta 0, we have seen delta less than 0 and we have seen delta greater than 0. So let's put delta is equal to 0. So if we put in this equation delta is equal to 0, root 0 becomes 0, and we are left with only x is equal to b by 2a minus b by 2a. Sorry. So what does this mean? We've seen that for any quadratic equation there are two values of x. So this means there are two values of x, but they are both are same. That means the roots are equal roots. So the roots are equal. So these are some conditions. These are the three conditions for discriminant. Sorry, these are the three conditions for a discriminant. If delta is less than 0, then it is imaginary. Then the roots are imaginary. If delta is greater than 0, then the roots are real. If delta is equal to 0, then the roots are equal. Discriminant, and this is nature. So this is an important thing to note down. Okay, this so we can use discriminant to find the nature of the roots of the quadratic equation. So these are some problems we can solve. Okay, so let's solve the problems. Find the value of k for which the following quadratic equation for which the given value of x the root of the given quadratic equation. Given value of x is the root of given quadratic equation. Okay. So for this number one problem, 3x squared minus kx minus 2 is equal to 0. X is equal to 2 is the root of this equation. That means if we put x is equal to 2 here, this equation becomes true. So let's put 2 squared minus k into 2 minus 2 is equal to 0. Is equal to 0 is given. So 3 into 4 minus 2k minus 2 is equal to 0. 3 into 4 is 12. 12 minus 2 is 10. So it is 10 minus 2k is equal to 0. We want only k value. So I'm going to do is let's write this equation 1. So I'm writing the equation 1 here. 10 minus 2k is equal to 0. I'm adding 2k on both sides. I'm adding 2k on both sides. Okay. So here 2k 2k will get cancelled, and 10 is equal to 2k. And if I divide both sides by 2, we are left with k only. 10 over 2, 2 ones are 2, and the 2 fives are 10. So I get k is equal to 5. For problem 1, k is equal to 5. 5 is the answer for this problem. Same thing with this equation also. X is equal to 5 over 2. So let me put x is equal to 5 over 2 here. 5, sorry, 5 over 2 squared minus 27 into 5 over 2 plus k is equal to 0. So 14 into 25 by 4. 4. Let me write it as 2 into 2. Okay. 2 times 2 minus 27 into 5 over 2 plus k is equal to 0. Mhm. So, okay, 2 ones, 2 sevens, 14, and